Okay, so I have some examples here so we can come up with the three different rules for logarithms. Okay, so um, actually this one's not supposed to be here. We'll just do this one for fun right here. Okay, so and just to remind ourselves what the logarithm is asking us. So the logarithm wants to know an exponent that will make 1/5. So the exponent is going to go on this base, so it's 5 to the something would equal 1/5. Well, if I try to think of what to write on the 5, the first thing I realize is that it has to be negative to get it onto the bottom. And the second thing is that it has to be just a 1 because I don't really want to change it. So the exponent I have to write on 5 is -1, and then I'll get 1/5. So that's just reviewing how to interpret the exponent, or the logarithm here. Okay, so now let's move on to these ones, which are going to lead me into my first law or general fact about logarithms. So, log base 10 of 10. And remember, often you won't see this written, but I'm just writing it in for you to remind you that if there's nothing there, the base is 10. So if the base is 10 and the answer is 10, then what is the exponent? That's right, the exponent would be 1, because 10 to the 1 would equal 10. Okay, so I'll just go over that one more time. So what I'm reminding you is that what the logarithm is asking for is if you pretend there's a tiny little box just right here on the base. You're trying to fill in this box so that this 10 to this power will equal this. Well, obviously 10 to the 1 equals 10. Okay, so what would go in the little box here? 3 to the what equals 3? 3 to the 1 equals 3. So this again would be 1. And here, 2 to the something equaling to 1. So we can generalize this by saying that log, it doesn't really matter what the base is, so let's call it b. If we're trying to make that same number, then we just have to raise b to the 1. So log b of b is 1. Nice. Okay. So, that's our first rule. Log b of b, 1. The exponent you have to raise b to make b is 1. Okay, let's move on here. So again, we can review the idea that this is the base and I'm trying to figure out what exponent to put on it so I can get this result. So 10 to the what equals 10 to the 2. Well, 10 to the 2 equals 10 to the 2. This is almost as good as just having a 10 here and seeing that, hey, I just need a 1. This is showing me what do I have to put on 10 to make 10 to the 2? Well, obviously a 2. What do I have to put on 3 to make 3 to the 4? Obviously 4. And what do I have to put up here on the 5 to make it equal to 5 to the 8? Must be an 8. So generalizing it, this works for any base, so we call that b. If the base is again written here with some exponent, maybe we'll call it x, okay, then what number do I have to raise b to make it equal to b to the x? X. B to the x will equal b to the x. Okay, so we can always check our answers because the answer is an exponent. So if I take this answer, I should be able to put it on this base right here and get this result right there. So this is one way of checking. Okay, so x on the b to the x would equal b to the x. So this is great. Okay, now I just want to talk about one other way of looking at this. Remember we said that the log is the inverse function. Well, the log is the inverse of the exponential. So you see right here, I have the exponential function. So let's let f of x represent the exponential function. Okay? So then this right here is f of x. Now this is the inverse, which I show with this notation. So the inverse function of the forward-going function always gives me my x back. Okay? So here I've taken a number and used x as its exponent, and here this asks me to get the x back down. Okay, so that's just something for you to think about for a while, but this is my next rule right here, which I can just go ahead and use. So when I see log with the base, and then the base again with an exponent, I just write the exponent. Okay, let's move over onto this one. So log with a base of 3, so 3 to the what equals 1. Well, 3, I'm going to switch my colors, 3 to the 0 equals 1, because of the rule that any base raised to the 0 is equal to 1. So 3 to the 0 equals 1, so I need the 0 is my exponent. 5 to the what equals 1? 5 to the 0 equals 1, so 0 again. 7 to the what equals 1? 7 to the 0 equals 1. So 3 to the 0 equals 1, 5 to the 0 equals 1, 7 to the 0 equals 1. Any base raised to the power 0 is equal to 1. So log, doesn't matter what your base is, if you're trying to get a 1 out of it, you put a 0 on it. B to the 0 equals 1. So here are 3 rules of logarithms for us.